So for example, if you don't have a salt in your room, we'll be using a crystal salt to make it. For example, if you don't have a water, we'll go and buy some cool drinks. So that is what we are doing. We'll be replacing one item with the another item. So let me write the definition. The substitution network, so derived from the user generated suggestions for modifications, can be decomposed into many communities for functionality equivalent ingredients, and captures user preferences for elderly variant of a recipe. So what is the definition? So it is derived from user generated suggestions for modifications. Why did modification came? For example, when you are tasting the taste of when you are tasting the curry, so if your mother say that there is no salt in the curry, what we'll be doing, we'll be putting some sort of salt in that curry. So this is so what we are doing, we'll be substituting each and every salt with the new salts. So that is what it is. So modification then can be decomposed into many communities from user generated sessions for modifications. So coming to the substitution network algorithm, what we'll be doing, we'll be replacing for example, if consider there is a recipe A and recipe B, or item A and item B, we'll be replacing A with B or B with A. So we'll be substitute B for A or B for B, or B instead of A or B instead of B, sorry, B instead of A or A instead of B. So that is what we'll be doing. So in algorithm, nodes are nothing but the ingredients. So what is the edge weight? Edge weight is nothing but the probability of B with respect to A. For example, if we are substituting B, we are replacing with the A with B. So what will be the probability? Probability will be B by A, which is the proportion of substitutions of ingredients A that suggests ingredient B. So what will be the edge weight? So what is the edge weight here? Edge weight is nothing but the number of recipes containing A and B divided by the number of recipes. When coming to the substitution network, it is edge weight is probability of B by A, which is the proportion of substitutions of ingredients A, ingredient A, that suggest ingredient B. So we will be replacing one recipe with the another recipe. For example, let us consider our dairy items. In place of oil, what we can use palm oil or olive oil or fish liver oil, anything we can use. For example, coming to the sweets, there are different types of sweets. For example, what we say, badshah, jaggery, jalebi. So we can replace anything with the sweets. So that is the examples of substitutions. So coming to the preference network, substitution network and user preference network. So what we'll be doing, that we will be creating an edge from the ingredient A to B if ranking of A is less than the rank of B. If what will we say, for example, if dish one, there are two dishes, dish one and dish two. So if dish two is not much, if dish one is not good, so what will be the rating of the dish two? So dish two will be increased, because the servant will be feeling that dish one is not recommended for the restaurant people coming to the restaurant with the dish one. So they will replace dish one with the dish two. I hope you got it. For example, what we'll be doing that, for example, if you don't have a pen, we'll be replacing it with pencil. So if you don't have a pencil, we'll be replacing with a pen. So that is what it is. So based on the requirement, we'll be changing. So in preference network, what we'll be doing, we'll be creating an edge from ingredient A to B if ranking of A is less than ranking of B. So this is not here ranking or rating, anything, it depends. So ranking or rating or the review. So coming to the weight of preference networks. So how do we calculate? So we have calculated PMI in how do we calculate PMI in complement network? PMI is nothing but the log of probability of A comma B by probability of A into probability of B. So but whereas coming to the substitution network, what we are dealing with the substitution, right? So we will be taking a pair of recipe pair from A to B. So which is the replaced by? So we'll be weight which has been replaced. So weight of preference network, that is nothing but PMI is PMI of A turns to B is equal to log of probability of A turns to B, that is A is replaced with B, by probability of A into probability of B. So this is what we'll be doing. So when a new item is replaced with A, we'll be finding that what is the probability that A can be replaced with A can be replaced with B. So then later we'll be proceeding with our rating concept. So what is probability of A turns to B? Is nothing but the number of recipe pairs from A to B by number of recipe pairs. So what might be the correlation or the PMI between them? So PMI should be equal to 0.72 or should be less than or equal to 0.01. So but whereas coming to the complement network structure, PMI is 0.01 and P is less than 0.001. P or rho, anything you can call it as. So coming to the correlation. So what is the network preference and substitution network is P is equal to 0.72 or comma P less than or equal P less than 0.001. So this is what these are the two so this is the correlation between each and every recipe when the item is replaced with another. So these are the two types of ingredient network, that is one is complement network and another one is the substitution network. So let us come to the prediction task. Prediction and task. So in prediction task, we'll be make sure that the item is correctly predicted. So there is a one flow chart for that. First we have to take the data, collect the data, then we should clean the data such that there are no null values, and when the item is duplicated, etc. Then we'll be constructing the ingredient network. So from ingredient network, for example, when a user gives the input that I need only chicken types, then we have to build the module such that the module should generate all the types of chicken curries, like chicken rolls, chicken drumsticks, chicken curry, chicken fried, chicken 64. So like the different types of recipes we will be generating. So later, based on the review of the user, we'll be predicting the rating of the recipe. So that is what the flow chart is. Let me write the methodology or the prediction task. Methodology. So what we'll be doing? First we'll be collecting the data, then later will be clean data set will be given. Clean data set. Then we have to construct. What we have to construct? We have to construct the ingredient network. To construct the ingredient network, for example, if when a user gives the user input such that if we need any particular items list, we have to generate that new recipes to the user. So based on the user review, user evaluation or review evaluation, we have to make a rating prediction. So for example, if he gives the low rating, so we'll be removing that item from the menu from the for the next user. So rating prediction we'll be doing. So what we'll be doing later, from the rating prediction, we'll be improving the ingredient networks to ratings. So based on the ratings they have provided, we'll be changing the menu and we'll be rating it again. So that is what we'll be doing it here. So here we'll be train predictive model with network features. For example, the dish is good. For example, if the most of the people told that the dish is good, but some of the people told that the dish is not good, so we'll be removing those negative comments, and we'll be placing with the mean comments, mean or that absolute comments. For example, if there are 5, 2, 3, 4 values and there are 0, 0, 0 values in the consider this as the ratings. Consider this as the rating one an item got. So they are make 5, 6, 7, 8, 9, 7, 10. So 10. So consider this 3 zeros and 3 0 and 2 3 2 5 3. So what we'll be doing in some cases is that, so we'll be taking mean of this. So what is the mean? So 10 by 3 is 3.3. So we'll be replacing every 0 with 3. So 3 and 3. So this is one of the technique in machine learning. So to clean the data sets, that it comes under cleaning the data and pre-processing the data sets. So this is the methodology where we'll be predicting the rating of the task. I think this flowchart is cleared. So first we'll be collecting the data sets, then later we'll be cleaning the data sets, and we'll be constructing an ingredient network. So from ingredient network, if the user provides the particular item, so we'll be generating the list of the items which an user asked. Then later we'll be evaluating based upon the user requests, and we'll be making a table of the rating predictions. So that is what the entire methodology depends on. For example, if two chicken curries are placed together, we will be finding that which is one is the tastier one, which is one is not that much good. So what is the precision task will do based on the features, based on the nutrition level, based on the ingredients they have used, or if they mix any types of species, spices, etc. So based on all those things, we'll be predicting whether the item is good or not. So what we have discussed so far in this overall video, so we have discussed about the predicting recipe rating using ingredient network. So then we have seen what is an ingredient, how the community is built in using the ingredient network, and then later we have went to the recommendation using ingredient ingredient network. So then how the information system works, and how the information system application works, and how we'll be doing data mining techniques. So then later we have moved into the recipe mining. So in recipe mining we have seen the 3 types of recipe mining, that is cooking methods, ingredients, and predicting tasks. So then later we have moved into the combining ingredient, that every ingredient should be combined into 2 or combined so that to make a one special network or community. So then later we have moved into the types of ingredient networks, that there are 2 types, that is complement network and one other is substitution network. What is complement network? So it will be checking that there is any cofactor frequency level, that is if the 2 dishes have the same common similarity ingredients. So that is what we'll be checking in the complement network. So this is the algorithm. So nodes are independent. Nodes are nothing but the ingredient networks. So every ingredient is independent of itself. So we'll be finding PMI, that's pointwise mutual information, using this formula log of probability of A comma B by log of probability of A and probability of B. So then later we have seen the substitution network. What is substitution network? In place of one ingredient, we'll be using another ingredient, that is known as substitution. So then later we have derived an algorithm where will be PMI is calculated as PMI of A turns to B, that is A is replaced with B, then log of probability of A turns to B, that's A replaced with B, by probability of A and probability of B. Then we have find the correlation. Then we have seen the entire flowchart in a prediction prediction task. So you can make a Python program or C program or any program based on this prediction. For example, if a user gives the input as a tomato curry, we have to make each and every list visible to the user, that what are the items which can be made with the tomato. So this is the program. In case if you have time, just try to make it. So that's all about this. That's all about the ingredient network. Thank you.